Hello, everyone. Welcome back. Thank you for joining us. I'm Steve.
And I'm Scott.
And together we are Backyard Musings, broadcasting live from the People's Republic of California.
Yep, in a fairly good place in Apple Valley. But yeah, we are in the People's Republic of California. And we're talking science and technology, as usual.
Yes, sir. This is an interesting one. Earth is spinning faster this summer, making the days marginally shorter and attracting the attention of scientists and timekeepers. July 10th was the shortest day of the year so far, lasting 1.36 milliseconds, less than 24 hours, according to data from the International Earth Rotation and Reference Systems Service and the US Naval Observatory, compiled by timeanddate.com. More exceptionally short days are coming on July 22nd and August 5th, currently predicted to be 1.34 and 1.25 milliseconds shorter than 24 hours, respectively. What does it mean? Would you like to know more?
Well, I didn't notice anything different those days, did you?
No, I didn't.
Yeah.
My
And
clock
I
went off.
know, what is it the 26th of 21st or the 26th of July is when the days started getting shorter anyway, right? The summer solstice, is that what they call that?
No, that happened in June. Didn't that happen in June?
I thought it was in July.
July? Okay, all right.
July. And then it
Oh,
happens again in
October.
October.
October it turns and you start getting
Winter solstice.
sorry, December.
December. Yeah.
Yeah, it turns and you start getting longer days.
Maybe you are right. Maybe it is in June. I think it's every 6 months. So
There's
anyway,
there's an equinox that's like in between June and December and January and June. The equinox is different from the solstice. Yeah.
right. All right. So atomic clocks count the oscillations of atoms held in a vacuum chamber within the clock itself to calculate 24 hours to the utmost degree of precision. We call the resulting time UTC, or Coordinated Universal Time, which is based on around 450 atomic clocks and is the global standard for timekeeping, as well as the time to which all our phones and computers are set. And they're always the same.
Global standard.
Yeah. Okay.
Okay. Astronomers also keep track of Earth's rotation using satellites to check the position of the planet relative to fixed stars, for example, and can detect minute differences between the atomic clock's time and the amount of time it actually takes Earth to complete a full rotation. Last year, on July 5th, 2024, Earth experienced the shortest day ever recorded since the advent of the atomic clock 65 years ago, a 1.66 millisecond less than 24 hours.
I mean, is that even noticeable? Millisecond?
Milliseconds. I mean, if you get 100 of those, it's 1 second. You know?
Wow.
I guess
Okay.
if it keeps getting off, you might 100 of those, you'll have 1 second off.
I better start using my time more wisely. Okay, here we go. In 1972, after decades of rotating at relatively slowly, Earth's spin has accumulated such a delay relative to atomic time that the International Earth Rotation and Reference System Service, I didn't know there was one, mandated the addition of a leap second. Is that maybe that's kind of like a leap year, I guess, right?
Yeah.
To the UTC. This is similar to the leap year, there we go, which adds an extra day to February every 4 years to count for the discrepancy between the Gregorian calendar and the time it takes Earth to complete one orbit around the sun. Okay.
It's all confusing, man. It's interesting. Since 1972, a total of 27 leap seconds have been added to the UTC. That's half a minute almost.
Yeah.
But the rate of addition has increasingly slowed due to Earth speeding up. 9 leap seconds were added throughout the 70s, while no new leap seconds have been added since 2016. In 2022, the General Conference on Weights and Measures voted to retire the leap second by 2035, meaning we may never see another one added to the clocks. But if Earth keeps spinning faster for several more years, eventually 1 second might need to be removed from the UTC.
Are you kidding me?
Right?
So somebody's got to sit there and watch this, whether or not we're going to do it.
Hey, I'm just the messenger. Okay, don't shoot the messenger.
I know, but that could put people out of jobs, right? If they're not going to these seconds or
hey, I want to get paid for that second.
Yeah, what a job. All right, the shortest term changes in Earth's rotation, Agnew said, come from the moon and the tides, which make it spin slower when the satellite is over the equator and faster when it's higher or lower altitudes. Okay.
This effect compounds when the fact that during the summer, Earth naturally spins faster, the result of the atmosphere itself slowing down due to seasonal changes, such as the jet stream moving north or south. The laws of physics dictate that overall angular momentum of Earth and its atmosphere must remain constant, so the rotation speed lost by the atmosphere is picked up by the planet itself. That's mind-boggling. Similarly, for the past 50 years, Earth's liquid core has also been slowing down, with the solid Earth around it speeding up.
Okay. By looking at the combination of these effects, scientists can predict if an upcoming day could be particularly short. While one short day doesn't make any difference, Levine said, the recent trend of shorter days is increasing the possibility of a negative leap second.
Yeah, they have to shave it off. The prospect of a negative leap second raises concerns because there are still ongoing problems with positive leap seconds after 50 years, explained Levine. Because so many fundamental technology systems rely on clocks and time to function, such as telecommunications, financial transactions, electric grids, and GPS satellites, just to name a few, the advent of the negative leap second is, according to Levine, somewhat akin to the Y2K problem. If you remember,
yeah,
you were alive
2000,
in
right?
2000. Yeah, there was this fear because of computers. You know, what are the computers going to do? Stop at 1999 and go back to zero?
Yeah, wasn't that a deal where that was almost like a push for people to buy new computers, right?
Yeah, it was hysteria.
Yeah.
And Prince wrote a song about it, Party Like It's 1999, like the world was going to end.
Right.
Okay, the moment at the turn of the last century when the world thought a kind of doomsday would ensue because computers might have been unable to negotiate the new date format going from 99 to 00.
And that never happened. We just rolled right through it, right? Yep. And now here we are.
Just 20... like the Mayan calendar ended at 2012, and we're still here.
Yep, still here. Effects of the current ice age are also a contributing factor to the issue of a leap second, but in a surprising way. While global warming has had considerable negative impacts on Earth when it comes to our timekeeping, it has served to counteract the forces that are speeding up Earth's spin. Okay, so they're saying global warming, no considerable impact.
So when you hear global warming, folks, just think of it as ice age. You got climate zealots want to say climate crisis and global warming. It's just ice age. We're in the warming part of an ice age. Okay.
Yeah, we have, and here in the desert, we have global warming from July until sometimes the middle of October. But sometimes it starts in June.
Yeah.
But right now we're in a cooling trend and we're almost into August.
Yeah.
So are we global cooling?
It's been nice cooling trend.
Yeah. But are we global cooling right now? Yeah. I don't know. Anyway.
A study published last year by Agnew in the journal Nature details how ice melting in Antarctica and Greenland is spreading over the ocean, slowing down Earth's rotation, much like a skater spinning with their arms over their head, but spinning slower if the arms are tucked along the body. Meltwater, I thought when they're tucked, they go faster, and when they're out, they go slower.
I thought so too.
But spinning slower if the arms are tucked. Okay, meltwater from Greenland and Antarctica ice sheets is responsible for a third of the global sea level rise since 1993, according to NASA.
Okay, the mass shift of this melting ice is not only causing changes in Earth's rotation speed, but also in its rotation axis. According to the research led by, Benedict Soja or Soha, Soja, an assistant professor at the Department of Civil and Environmental and Geomatic Engineering of the Swiss Federal Institute of Technology in Zurich, Switzerland.
Swiss timepieces, they are exact.
Yep. Yep. If warming continues, its effect might become dominant. At the moment, potentially having more time to prepare for action is helpful, given the uncertainty of long-term predictions on Earth's spinning behavior. So,
folks, the Earth has been spinning for billions of years, and it's going to keep spinning. Okay,
yeah.
and whether we lose a second or gain a second, it really doesn't matter. The Earth is the sun's gonna rise because we keep rotating.
Yep. And we all know that there's somebody in control. So
yes, there is.
And it ain't anybody in Zurich, Switzerland, or whoever these timekeepers are. We know that there's a higher power in control here. So anyway, good story.
All right, folks. We'll see you in the afternoon.
Take care, everyone. Thanks.